Hey there and welcome to the Code Wrinkles channel. In this video, I want to show you how you can get started with event sourcing in your .NET applications with a library called Marten very fast. Event sourcing is an architectural pattern that's worth investigating, and unfortunately I found it fairly difficult to get started with that. Usually what happens is that materials that you can read or find online are trying to really convey everything about event sourcing just at once. So my approach to this is to strip it down to the very most important things that will help us or enable us to understand the approach to event sourcing and how we can get started with that, implementing it in our .NET applications very fast. Before we get into it, I just have an announcement to make. I recently released my first ebook called API Versioning for the Real World. It's a very short one, but it contains some very condensed and important information regarding versioning your APIs. Because you see, versioning APIs is not just a matter of dropping a v1 or v2 in the URL. It requires more understanding, more context. It requires understanding why, when, and how we should even do that. And there's really more to it. Now, reading this ebook will for sure give you some information and knowledge that will make you stand out from all other developers. If you want to read it, make sure to head over to the description of this video and you'll find the link to the ebook there. Now let's get back to event sourcing, and the first thing that I would like to do is actually start from a very practical example. And this is a front-end application. Let's say it's an application designed for tracking workouts or activities, especially for runners. And that's something that I've been working on personally for quite a while. Now let's assume this very simple functionality that you need to implement when you start out an application, which is the user registration. So here, for instance, I would have this join for free and I can click on that. And here, first of all, I need to, well, provide some information about the email and the password. So here is my email and my password. I click here on sign up. Then probably something happens in the backend and I'm redirected to this other part, which wants, for instance, to understand something about me. So let's also fill in these details. That should do it. So now if I click here on save details, once again, probably there will be a call made to the backend. And then I am presented here with this other screen. That's all part of the sign up information, because obviously this application needs some information from me in order to be able to work correctly. And some other information like the maximum heart rate, minimum heart rate, resting heart rate, and VO2 max. Now, if I click here this save health information, right now nothing will happen because in my Angular frontend, I don't really have a working redirect. So if I click here, you will see that basically it cannot find the route where it should be redirected. How would you model this entire behavior in a very traditional way? Well, you will probably end up having something like a database structure that's similar to this one here, where we have all the information about the athlete. So when the athlete registers, we just update all the information that we receive in the different steps from the front end. But also further in the application, probably there will be a user profile where the athlete can edit or adjust his weight, maximum heart rate, and other stuff that we have already provided. So we have here only one single entry of an athlete, and every time that an update occurs to this athlete, we would go here to the database and perform the update. For instance, like, okay, what is the resting heart rate? I update it and it will be 56 or 58 or whatever. Imagine now that one of the stakeholders of the application, like the product owner, comes at a certain point to you and asks, okay, but this athlete X, maybe with this certain name or user ID, whatever, doesn't really matter here. I want to know when was the last time that this athlete logged in, or how many failed login attempts did we have for this specific athlete. Now, if you look at the database that we have previously seen, you can simply tell this information. So it's an information that's not available in your application right now. So you need to add an additional functionality. Probably you will end up having an additional table for login attempts. And every time this athlete tries to log in, you also need to make sure that you persist that information in the new table. So you would need a transaction for that. But then the athlete at a certain point will want to know, okay, what was my weight evolution? So how much did I weigh 1 year ago? Once again, with the setup that you would have traditionally or with the traditional approach, you will not have this information. So again, you need to address this and add the new functionality. Probably you will have a new table to add to the database, like the weight history log. And you have to make sure that every time an update of the weight comes in, you also populate the new table with the information so that you can then replay it for that user. Event sourcing as an architectural pattern comes in to solve exactly this type of problems, because the core concept in event sourcing is that you don't actually store the athlete itself in the database, but instead you store just all the events that happened related to that athlete. So the athlete clicked one button to provide the personal details. Okay, here's a event that, well, notifies or that testifies that this athlete tried to register giving these following details. Then the athlete gives the body information. Cool, we have another event that testifies once again that at this certain moment in time, the athletes try to update their body information providing this certain type of values. And then whenever, for instance, the athlete wants to update something, there will be an event triggered and that event will be stored in a database. Now, how do we get all this information to play together? Because we still need the concept of athlete in the application. And in event sourcing, that's the whole idea behind it. So you have this idea of an athlete, like you probably will have a class and we'll see this in action just in a few seconds. But then when you want to create an instance of that class and basically populate it with the information that you have in the database, you actually take all the events that you have regarding that specific athlete in the database and replay them in historic order. So first you apply the first event and check the state of the athlete after the first event. Then the second event gets applied and you get the state of the athlete after the second event was applied. Then you apply the third event, the fourth event, and so on and so forth. So basically you replay the entire history until you get the current state of the athlete. So how do we do this in practice? First of all, we need to make sure that we have all the required packages installed. As I said, we will use Marten to actually help us out with getting started with event sourcing. Marten is a really cool library that helps us really implement all these concepts very easily, because we don't really need to go to the low level and see how exactly do we do that, but instead we can just apply the event sorting concepts using this library. Now, Marten, on the other hand, relies on Postgres. It only works with Postgres, and that's why you also need to make sure that you have a Postgres installation at hand, and probably it will be useful to also have a PG admin, like for instance I have it here, and I have created this new ES intro database that I will use for this event sourcing tutorial. Once you have everything up and running and you are set up with Postgres and you have installed Marten, then we can obviously go to the next step and see how do we actually implement this concept of event sourcing in our .NET application. And we'll try to mimic or to replicate exactly the behavior that we have seen in the browser just a few seconds ago. Here I have some source code that I have already prepared in advance just to set up the entire context for implementing like event sourcing. So we have a controller with the specific actions that will model basically the calls that the front end might make here to our API, and for which we will use event sourcing to actually model the entire application. Obviously, no matter if you're using event sourcing or not, we still have a class that's athlete that will have an athlete ID, and that will have, in our case, a very simplified version of just personal information like this one and some body information like this one. These are basically the details that we can generate or specify in the UI, and that can be part of the API call to actually generate this type of stuff. For now, it's very simple. You'll see that we don't really have any method here, but we'll populate this athlete with some stuff just in a few minutes. There is a lot of source code in this video, so if you want to get access to the source code, make sure to become a CodeWrinkles member. Like on the channel, on the YouTube channel, you see a membership button and you can press to apply to become a member, and all ambassador members, so members on the ambassador tier and higher, after each video they receive information on how they can get the source code. So make sure to become a CodeWrinkles ambassador member if you want to get the source code for this specific video. Now that we've seen the current setup, let's try to configure Marten and get started and implement the functionality. First of all, make sure that in the app settings.json file you add the connection strings, and I have called this connection string Marten, and I have provided here the connection string to my local Postgres server that I have installed. So make sure that you also have something like this in place so that you can get the connection string. To get started with Marten, the basic configuration is actually very simple and easy to follow because it follows the standard schematics that we have literally in all .NET libraries. First of all, we just need to get the connection string that we have in app settings.json, and then we can simply use these builder services, then add Marten. Now, add Marten obviously takes in these state options where we can provide different options, and there are literally a lot of things that you can configure. But right now, for the getting started part, I think this is the most bare bone configuration that we can actually use. We just need to provide a connection. Here we provide information that I want to use system text to JSON for serialization. And here there is one other thing that I used is this auto create schema objects. This will help you or help Marten to basically create the missing schema objects. Like if you start the application and something is not there in the database that Marten would kind of like expect it to be there, it will create it for you instead of just throwing an exception. So I think that's a very nice feature to have, and I have turned it on. And with this configuration, we are basically ready to go. Now, the first thing that we need to think about here is, okay, what happens in the application for the first time? Like the user provides a username and a password, and it also provides like the first name, last name, and so on and so forth. Now, when the user clicks the button, it means that something happened in the application. So in event sourcing, we concentrate on the actions that happened in the application. These actions can be triggered by the user, like by clicking a button, or it could be triggered by a system, like by something else happening in the application will generate a new event that will make also other changes to the entire system. But here right now, to keep it simple, is just this idea, hey, the athlete clicked a button, like provide personal details. Cool. Now it means that this is an event. To capture all the events that might be possible for our application right now, I have created this athlete events class in which I'll add records for all the possible events that we'll have. So the first thing is we'll have this athlete registered, like when the athlete clicked the button, the athlete registered for our application, providing this type of information. Obviously, the athlete ID is not provided by the athlete directly, but it will be generated by us, and we'll see just in a few seconds. And then obviously we have the first name, the last name, the date of birth, and the gender. So that's the event that happens. Let's now move over to this athlete service class, which right now is empty, but we'll populate it right now. First of all, we need a service from Marten, which is the iDocument Store. Now, this iDocument Store service is basically the connection that will help us to work with Marten and use the functionality to store events, for instance, to the database, and later, as we will see in the video, to actually get those events or to create the athlete from those events and so on and so forth. Next, we can create our first method here, and this first method would be simply this task of registration response, which is what we will return, and it will get the athlete registration. That's basically the contract that we'll get through the API, and then also the cancellation token. Here's what we need to do next. First of all, we need from this iDocument store to create a new session to interact with. And we can do this by using this var session equals store lightweight session. Now we are using this because we want to make sure that this session is disposed right after it is not used anymore. The next thing that we need to do is to create an identifier for this athlete that we want to register right now, because the registration basically means that we need to create this athlete from scratch. And now comes the event sourcing specific part. The next step that we need to perform is, okay, we have this information in this service. We know in this method that our task is to actually register an athlete. So it means that we need to create an event for the athlete registration. Therefore, we have this var registered and we have new athlete registered, where we specify the identifier that we have defined earlier, and then all the details for this event that we get from our athlete registration contract. And that's how we created the event. So now we have an instance of the event, and we need a way to actually store this event in the database. To do this, we simply need here session. On the session that we have created, we want events, and here we have this start stream, and this is a generic one, and we specify that the stream is of type athlete, and then we specify the identifier that we have just created, and then we specify the event. And this means that we need to talk a little bit about this concept of stream, because it is a fundamental concept in event sourcing. Now we have an athlete, but we might have in our application a lot of different athletes, and each athlete would generate its own events, like this athlete X registered, the athlete Y registered, the athlete X updated their profile information, or athlete Y updated their profile information. So how do we know exactly which events belong to which athlete, right? So we need to have this common understanding in this application. And this is where this concept of streams come in. Now, streams are, as the name implies, simply a grouping, a stream of events that flow, but that are specific for a certain identifier. And that's why when we start the stream, we need to specify the identifier. So what we do here is that we make the identifier of the stream to correspond to the identifier of the athlete. And this is how we can guarantee that all events that we have in this stream are only related to the athlete that we register right now. So in the end, for really each athlete that we'll have in our application, there will be a separate stream that will be stored in Postgres, and we will take a look at that just a little bit later. So right now, the only thing that we need to do is simply save the changes, and we can use this await session save changes async and passing the cancellation token. And then we have here this, we return the new registration response because that's what we said according to the contract that we will return, and we'll simply just return this to the front end. We can now move to the athletes controller and wire everything up. Now in this athletes controller, I have already injected the athlete service, and this will be very easy because the only thing that we need to do is, well, having this for result, and we await the athlete service and register athlete. We provide the registration that we get from the body of our API call and pass in also the cancellation token. What we'll then return is this result okay, and we'll provide the result. Now, obviously, please bear in mind, usually you would have to return a created at action, but right now for me, it's just important to showcase how we wire up this functionality. Let's now move over and implement the second step of our registration process. Now here we remember that the athlete needed to provide a lot of information about, let's say, his body or her body, like the height, weight, resting heart rate, and this is very important information if you want to track your athletic performance. Now the idea is that here we have a contract like this body info update where the user will provide all this type of information like the height, the weight, the maximum heart rate, minimum heart rate, and VO2 max. Now, theoretically, we need to also model these as events because that's how we do event sourcing. Now, the question is, how would we model this? Because if we have something like an athlete body info updated, that might be helpful, but then we would lose the ability to understand exactly historically what changed for that specific athlete body info. Because let me go to the athlete and try to understand this. The idea is that, for instance, whenever the weight changes, I have to recalculate the BMI. And basically, I want to also give the user the opportunity to see his or her evolution on the weight throughout time. So it would be important to capture this type of information. The same goes for the resting heart rate, which might change with the evolution of the athletic performance. And when also the resting heart rate changes, some other things might need to change as well. So that's why it's important to kind of like understand and keep track as these type of updates as individual events. So instead of having just one athlete body info updated event, let's try to make it a little bit more granular. So I'll go back to my events class here, and I'll add a bunch of different types of events like athlete weight updated, athlete height updated, athlete resting heart rate updated, then the updated for the max heart rate, and then for the VO2 max. So you see that I have in total here 5 different events that actually model the change that could occur at the level or for the body information of an athlete. And each of these individual changes can be then tracked historically through time and see how they actually evolved. Let's now move over to our athlete service and implement this functionality following the event sourcing architectural pattern. First of all, in this service, I will create a method that is called this set initial body info. It will return a task of body info response. We get in obviously the body info update that we get from the API and the cancellation token. The first thing that we need to do is, like we did before, using this store to create a new lightweight session, and make sure to use this using keyword here. We also need a timestamp for each measurement that we have for each event that might occur here. So we get the datetime offset UTC now. As we are here in this set initial body information method, we already know, for instance, that we need to apply several different events for each type of change that we want to track independently. So we need an event for this athlete weight updated, we need an event for height updated, for the maximum heart rate, resting heart rate, and the VO2 max. Now, I want to say once again, this is a very simplified version so that we can get started and understand this new way, this new mindset of modeling our software and modeling our systems. Things can get a little bit more complicated here because what we would regularly do is we would kind of like need to rehydrate and get the athlete aggregate and then check which events can be applied to that aggregate so that we make sure that we don't have corrupt or wrong data in our application. However, for simplicity, once again, I want to keep everything as simple as possible, but there will be more videos on this topic, so we'll cover more in-depth topics in later videos. For now, we know that we have all these events and that we need to apply them because the athlete just pressed a button to update his or her body information. Now, as we are here, we already know that if the athlete wants to update their body information, it means that the athlete is already there. So it means that we already have a stream for that athlete. Now, in that case, what we can do using Marten, we can have these events, but instead of starting a new stream, we simply use this append. Now, when we want to append, we can either append one single event, or we can apply several different events, because if we take a look here, you see that it takes in a param of object which represent our events. Now, the thing is, once again here, that the stream ID should be the ID of the athlete, because for each athlete, we will have a stream that basically is identified by the athlete ID. Now we can simply use the session to save all the changes, and then we can construct this new instance of body info response and return it to the caller, which is our controller. And since we talk about our controller, let's move over to the controller and also implement this basic functionality here and wire everything up. Here is the update body information method that we use, or that we use to actually trigger this type of behavior in our application. The first thing that we want to do here is to actually take the athlete ID from the route and assign it to this body information. And to do that, we will have this athlete info. We say that body info with, and basically we create a new record that will contain all the exact information, but it will include the athlete ID that we have specified here. Now we can simply call our service, the athlete service, and the set initial body information method, pass in the athlete info and the cancellation token, and then we can here return OK, and then we'll return the result. And now also this functionality is wired up. The next thing that we want to do is, obviously in our API, we want to expose the functionality to be able to get an athlete, like to see the information of an athlete. So let's see how we can do this using or follow or in this event sourcing architectural pattern. To do this, I will return back to my athlete service here, and we'll obviously need to implement a new method for getting an athlete by ID. So this would be a very simple task of athlete get athlete by ID, and we just provide the user ID. Now, in this case, it is a GUID. However, here is the first thing, or another thing, that we need to understand exactly how this event sourcing works. So now what we need to do is actually get all the events that are in a stream with this specific ID, and based on those events, basically create an up-to-date athlete instance with all the information so that we can return it to the caller and in the end display it or return it from our API response. This means that there are some things that we still need to do. We need to implement some functionality. Now here we could either implement our own logic for, okay, taking all the events and applying them one by one and getting the up-to-date instance, or we can leverage some functionalities of Marten to actually instruct Marten how it can do this on its own. Now here, since we're using Marten, it's a library, this is kind of like a very opinionated approach because we need to implement things in a certain way in order for Marten to be able to reconstruct or to aggregate an instance of our athlete based on the events that are in a stream. And here the convention is that we need to supply this type of public void apply methods, and we need to supply an apply for each of the events that might occur on this athlete. And this is how Marten knows exactly, okay, if I get an event, it looks up through the apply methods that we have, and if it finds an apply method with the type of event that it needs to process, it will simply execute that method that will in turn actually alter and change the state of our athlete. For instance, when we register an athlete, we have this apply method, and then we know that we get here in this case an athlete registered event. And here we implement our logic on how we want to set the state of our, let's call it aggregate. And here we have the athlete ID. We get this from the event, personal information, and then we get the first name and last name also from the event. But also we have some information in the registration event, which is the date of birth and gender that we want to place in the body information also. So we create a new instance of the body information and set this information. But then we need to go one step further, and we also know that our athletes can update their weight. And therefore, we need an apply method so that Marten knows exactly what to call in order to apply this type of state change. Similarly to this, we need obviously to have apply methods for all the other events that we have during these processes that we have modeled. And now, as we have this set up, we can go back to our service actually, and now we have a way to kind of like instruct Marten or let Marten do its magic. The implementation for this service will become actually very simple in this case. And it would look something like this. First of all, as we did previously, we just need to create a new session and we have this lightweight session. However, right now there is some other thing that we want to do. We want to use this session, and on the event, we don't want to append a new event, but we want to aggregate all the events in a stream and return an athlete. That's essentially what we are instructing or what we are using Marten for. Now, we have a stream that represents all the events for the athlete, and we have the athlete, which we can call the aggregate. Now, Marten, what will do is it will go and look up all the events in that specific stream, and it will apply them one by one. So as it will apply first the register event, because that's the first event that we have, then it will apply this event, and after this event we'll have a weight. It will apply this event, and after this event we'll have a height. It will apply this other event, and then we'll end up having a resting heart rate. And last but not least, it will append these two events, and after which we'll have on the athlete the max heart rate and the current VO2 max. So when we finish this, or when Marten actually finished this aggregation, basically we have the most up-to-date version of the athlete. And then we can then just simply return it to the caller. So let's move then to the controller and implement this change, which is very, very easy to do, because here we have everything that we need. We get the athlete ID, and here we'll just use our service to call this getAthleteById method, and then we'll return the OK and the result. I want to keep things as simple as possible. There are other ways through which you can actually do that, and they might be a little bit more effective, but we'll talk about that just in a few seconds when we'll see right now how we can implement this idea of getting a list of athletes, because at a certain point in our application, we might want to return a list or a subset of different athletes. So how do we do that? Going back to our athlete service, we can implement kind of like this very basic method that returns an enumerable of athlete. We call it getAthletes, and we get just a cancellation token. Now, we would have an approach, we could use something similar to getAthleteById, for instance, so that we kind of like go and check all the streams, and for all streams, we then just create an aggregate of the athlete, put them in a list, and then return that list. However, if we have 100,000, 10,000 different athletes that we need to return, obviously that's really not optimal, because in the end, what we'll have to do is for each athlete to kind of like recreate the stream based on the events. And that takes a lot of time, and we cannot really afford it. And here is where another very important concept in event sourcing kicks in, and this is this concept of projections. Now, projections is, let's call it the read side of the data. Now, we have in the database all the events for all the different streams, in our case for all different athletes. But in order to speed things a little bit up, we can create like, okay, a view for that specific data, for that specific stream, that we can have different mechanisms to keep them in sync or up to date to the events that we have in the corresponding stream. And thankfully, Marten already has built-in support for projections, and if we follow some very basic and simple conventions, we can get started with these projections very, very fast. So to do that, I have already created this athlete projection class, which right now is empty. Now, how projections work in Marten, or how we instruct Marten to be able to also maintain a read view of the raw data of events that we have inside a projection is, well, first of all, define a class, and in this case, we inherit this single stream projection of athlete, which basically indicates that we want to define what the projection for the athlete looks like. How projections work in Marten is that as soon as we apply an event, or we have an event that it is stored in the database, we also want to capture that event and update the existing projection that we have. So in this case, we should simply use the same convention of having this public void apply method, only that in the case of the projection, what you get in is the event. Okay, so this event just happened. So how do I update the projection of an athlete? Because the stream is for an athlete. And then you specify that for the athlete ID, you need to specify the ID, you need the personal information, and you set the personal information from the event, and so on and so forth. Then we need to provide apply methods for all the possible events that we might have in our application. So we have an apply method for this weight updated, height updated, and so on and so forth. I will not go through all of them, but we have really literally all the events that can happen in our application right now. The last bit that we need in order to wire everything up together and using this projection is to actually instruct Marten that, hey, we have a projection. So make sure that whenever a certain event happens, that you also update the projection. And to do this, where we register and configure Marten, on the options we have these projections and add. And we can say here that we want to add the athlete projection, and here we can have this projected lifecycle inline. Now, there are different types of projection life cycles that we might have in Marten, but also on this, I will promise you there will be a more in-depth video to understand exactly how that works. But this inline projection, what essentially does, and we can get this information here, like the projection will be updated in the same transaction as the event being captured. So it means that when we have an athlete registered event, when this event is captured, we also update the projection. So everything happens in the same transaction. If something goes wrong, then neither the event is persisted. And now that we have everything wired up, we can come back here at our athlete service. And the implementation is actually very simple. First of all, we get a session from the store that we have. And here from this session, we can very easily get the athletes from a projection. We simply use the query. We say, okay, what we want to query, and then to list async. And then we just return the athletes. Now, remember that earlier I said when we were getting an athlete by ID, that there might be better options to do that. Well, if we have projections that also when you get an athlete by ID, instead of aggregating all the events, which takes a longer time, you could simply use the projection and use this session query of athlete, and we could use it with a first or default and then just specify the athlete ID, and we would get the athlete directly from the projection. So there is no need to actually replay all the events. But I just wanted to have both of these approaches, like to understand this concept in inverse sourcing of creating or of aggregating a certain instance by just replying or replaying all the events that we have for that specific stream. Now we can move over to our athletes controller, and the implementation here is actually very simple. So we can have var result, and the only thing that we want to do here is athlete service and then get athletes. Obviously, we also need a cancellation token here, so let's get it from the controller and we'll pass in and we'll have the result, and then we can just return the result. Now let's go one step forward and see everything in action and check if this implementation is actually working. Before I run this application, I just need to say that there is another convention in Marten that I have missed. And the convention is that the identifier of the document, like the identifier of our athlete in this case, needs to have the property name set to ID and not athlete ID as it was previously. So previously we had it like an athlete ID, but in this case, Marten will just simply throw an exception. So what we need to do is kind of like replace this with an identifier. And obviously I needed to do this also in the projection. So here's the projection, and you say that I have modified this to be athlete.id. And now I think that everything should just work fine. So let me just run the application. And I have here Postman, and I have already prepared here the request with the first name, last name, date of birth, and then gender. And then I can just simply send the request. As you can see now, I hit the controller in this case, and then if I click on continue, I will hit this one. And here what will happen, we can create a session, we can create an identifier, we have a new athlete registered, and then we simply just start the stream. And then we will also save the changes for the stream, and we can just click on continue. So this is what we have done. We already have registered a new athlete. Now the second part of the process from which we have started, also looking at the UI, was the update of this body information. Now, what we don't know so far is exactly, okay, what is the identifier for that specific athlete so that we can specify the body information for. But we have this get athletes endpoint, and on this get athletes endpoint that I have also called earlier when the API was not running, we can simply click ascend, and you can see that we have got all the information about the athlete. So it means that also the aggregation of all the events that we have in the stream for this specific athlete have been successfully aggregated to a most up-to-date instance of this athlete. And then we can just simply take this identifier for this athlete and go to our patch method. And in our patch method, the only thing that we need to do here is now change the GUID. So I'll simply delete that. Should be okay. I place this identifier because I know that this is the athlete that I need. And then I just want to click here send. And then we see that we have successfully actually updated this. And if we go back to our get athletes, you see that the height, weight, kind of like they have default values, or they had default values before we have actually called this patch method that created different or a bunch of different events that updated the state of this athlete. So if we go once again here and click send, you will see that right now everything will be updated. And as you can see right now, we are reading everything from the snapshot. If we want to test out the method that we have created for kind of like aggregating an athlete by just replaying all the events that we have in the stream, we can simply just go here, add a new request, and I want it to be a get request. We can just use this identifier, but then we also need this entire one. We don't need the body info because we just want to get information for this athlete. And if I click send, it should work. And this time I got exactly the same result back, but it's only one single instance of the athlete. And the thing is that in this case, the athlete was created by replaying all the events that we had in the stream with this specific identifier. We can now go to pgadmin and see actually what happened here in this database. And as we can see, Marten has created here some things like the dog athlete. And if we go here, and I think we can just go here and view edit data and all rows, and we'll see exactly, okay, this is basically where we have the information about the athlete. And here is basically the projection. Then we have an event. And here is where we store, or where Marten stores all the events. So let me also go here and just view all rows. And here we can see all the events that have been replayed. And then we have a dedicated table where we have the streams. So if we go here on viewing this type of data, all rows once again, you see that as we have just one single athlete in our application, we have just one stream. And all the events that we've seen in the previous collection we see that they belong to a certain stream ID, and these are all the events that happened. And that's basically it. That's how easy it is to actually get started with event sourcing in your .NET APIs using this Marten library. As said, this was a getting started video, so a lot of concepts were really stripped down to very, very basic building blocks. And there are a lot of different things to consider when going for event sourcing. But if you like this video and you want to see more videos about how you do practical event sourcing in your .NET applications with Marten, then just let me know in the comments and I'll keep on creating videos that will go more and more in depth about how we can do this. If you enjoyed this video, don't forget to hit the thumbs up button so that you make it easier to discover for others on YouTube. And if you are not a subscriber to this channel, make sure to subscribe to the channel and also push the notification bell so that you can get always notified when there's something new happening on Code Wrinkles. And if you have any questions or just want to get in touch with me, don't be shy and head over to the comment section and leave me a comment, and I would be more than happy to get in touch with you. This being said, thank you very much for watching, and until the next time, I wish you the very best.